Moving ahead to section 2, exponents. We're going to skip scientific notation. Hopefully you saw this in physics first. We don't really see too much of it in pre-calc collectively, but you probably got a taste for that in physics. We're definitely going to be using a lot of the properties of exponents, which you should have seen a lot in Algebra 1 or Algebra 2. On your outline, there's going to be a big table here, which I'm going to refer to kind of sporadically because you should know at least how some of those properties work. If you need a refresher, of course, that table's there to help you out. We'll see a few exponential expressions, sometimes when we need to combine like terms or add exponents, knowing when to subtract exponents. We'll also see a few ways that we'll rewrite some of these. So we're simplifying almost all of the problems in this section, so a lot of the properties of exponents that are on the table again are going to come back. So if you get stuck or you need a refresher, please look at that. So with this, we're multiplying these two. I know we're multiplying because we have parentheses around both of these terms. Negative 9a to the 5th power, b to the 4th power, this product, multiplying with 5a cubed and b to the 6th. So I first focus on the coefficients because I think that's the easiest part. So I have this negative 9 and 5. Let's bring those together. So if we're multiplying negative 9 and 5, that should get us negative 45. Of course, if you're not convinced, you can check your calculator. The one property of exponent that is used next is going to be adding exponents with common variables. So hopefully we can also see this a to the 5th term and this a to the 3rd term. So we can combine these. How? How can we combine these further? I'll give you a moment. So hopefully you were saying that we should be adding those exponents, because if we take the product, a to the 5th multiplying with a to the 3rd, we should be rewriting that as a with an exponent of 5 plus 3, which is a to the 8th. So we'll include that in our answer. Continuing with b, we have b to the 4th multiplying with b to the 6th. Same song and dance here, adding our exponents, getting b to the 10th. For our final answer of negative 45, a to the 8th, b to the 10th. That's all we need. For the next portion, we have a little bit of a fraction, negative 63x to the 5th multiplying with y to the 9th, all divided by negative 7x to the 3rd, y to the 6th. So first focusing with our coefficients of negative 63 dividing by negative 7. I'll use a calculator for this. I'm a little lazy, so what? So we have negative 63, we'll use parentheses, negative 63 dividing by negative 7. If you're using your calculator for this, please make sure that you're using the negative symbol, which is down towards the right. This is going to get us 9 in the numerator. One of the properties of exponents says that if we have a variable in the numerator and the denominator, we can subtract that exponent from the denominator. So we should be thinking of this as x to the 5th, but then deducting 3, going with y, where we now have 9 and deducting 6. If we simplify this, 9x squared, followed up with y to the 3rd. That one's done. Problem 3 has a few different ways you can solve this. So the way that I'm going to show over here on the right, the left, is with flipping the fraction. So one property of exponent says if we have a negative exponent, we can flip it to the denominator. So we could expand this as negative 4b to the 6th in the denominator where the outside exponent is 4. Option 2 is just going to distribute all of this, but then eventually go towards the end. So we'll call this the distribution of b to the 6, also that negative 4. I think this is personally easier to evaluate. Eventually, you're pretty much distributing to all the exponents. There's an unwritten 1 on this 4 and this 4. So if you distribute to that, keeping in mind that you are distributing to a negative 4, so if you have negative 4, and you're taking this to the exponent of 4, you have 256. Keeping in mind it's a positive 256. Another property of exponents has parentheses for exponents inside and outside, where this would be multiplying, so this would be b to the 24th power. If you decide to evaluate with distributing, I think this takes a little bit more time, so I'm actually going to star this method. I think this is easier. But you could evaluate this as negative 4 to the negative 4th power, b to the negative 24th power. You can rewrite both of these as two different fractions if you want to, eventually getting up to that same outcome, 1 over 256, b to the 24th. That's 2. 2 different ways you can do 2. With problem 3, we now have kind of the same setup as before, but a little bit more intense. So we have that exponent on the outside with negative 4. I'm actually going to just follow through with this the same way I did with the previous problem, but with the approach I took on the left-hand side. So I'll be following through with this type of method. So I'm going to be rewriting this as 1 divided by all of this, so negative 55, x to the 12th, y to the negative 6th power, over 11, x to the 5th, y to the 2nd power. 4 is on the outside. I'm first going to just follow through with the coefficients. So negative 55 over 11 will eventually get me negative 5. If I combine the x terms, I'm going to have x to the 7th left over. Eventually, this y to the 6th can be added to the denominator. So y to the 8th. Keeping in mind that we have that 4 on the outside. From here, if we take this further, we can evaluate this as negative 5 to the 4th power. So keeping 5 negative, going to the 4th, 625. Distributing 7 to 4, so x to the 28th power. Also 4 to this 8, which would get us y to the 32nd power. This does look kind of goofy to have a fraction dividing by a fraction, so if you want to really take this further, you could take the reciprocal of this bottom fraction. So we're just rearranging it, just flipping that fraction around. You could say that this is y to the 36th power dividing by 625 x to the 28th power. So there are a few different approaches you could have taken for this problem. If you wanted to just distribute right off the bat, you can, but I think it's easier personally to look inside the parentheses, as I've said in the first section. So look inside, parentheses, then simplify what you can. As we saw, we had a lot of simplifying with exponents and with the coefficients, and then distribute the outside exponent. If you were stuck on anything here, please feel free to look back on this video, watch it as many times as you need to. If you're still stuck, please come into class and ask questions, unless you email me or do something if you're still unsure about what's going on here. A lot of these properties of exponents will come back, so please ask a question if you're stuck on something here.